All right, 2-2, piecewise functions. So on your homework today, it's going to be a little bit different than the notes because originally we were going to do my math lab assignment, but then in grade 3, I really liked the delta assignment. So you're going to do delta for homework today. So the first 5 questions on your homework is giving you a piecewise graph and asking you to evaluate the function. So that's going to kind of reinforce what we did last unit in 2-1. The next 5 questions on your homework is going to give you a function. So we're going to kind of ignore all the words here. And we're just going to look at the function c of t. And we're going to evaluate the piecewise function for that. So when you're evaluating a piecewise function, the important thing to do is always start from the right and looking at the domain. So if I ask you to find c of 30, we want to look and say, okay, is 30 between 0 and 60, or is it greater than 60? Between. So since it's between, we're now going to go over here to the left and plug in our value for t. But is there anything to plug into? No, so our answer is just 20. Okay. So same thing, c of 100. So is 100 between 0 and 60, or is it greater than 60? Greater than. So we're going to plug it into this expression here on the left. So we have 20 plus 0.4 times 100 minus 60. And you can either plug that whole thing in your calculator at once or break it into pieces. I do not care which one you do. If you plug it all in at once, though, what do you get? 36. Okay. Questions with evaluating piecewise function. Okay. On your homework, you're going to see a couple that maybe don't fit within that domain. So if I asked you to find c of negative 25, is negative 25 between 0 and 60 or greater than 60? Nope. So this would be considered undefined. Okay, so if it doesn't fit within your piecewise function domain, just consider it undefined. All right, so graphing. Depending on who you had as a teacher last year, graphing is taught different ways with piecewise function. I'm going to teach you in a way that's going to help you do your homework. Okay, so we have graph the piecewise function defined by f of x equals the quantity x plus 2 if x is less than or equal to 1. And 4 if x is greater than 1. So we're going to split this into 2 different functions. So the first function we have is f of x equals x plus 2 if x is less than or equal to 1. And we're going to make a table with 2 x values that are going to fit within the domain restriction of the piecewise function x is less than or equal to 1. One of the key things is that you're always going to use this x value no matter what. So we know we're using 1. So what is a value of x that would stay true within that inequality? So x is less than or equal to 1. What's another number? Negative 1, 0. It doesn't matter. I'm going to use 0. And then we're plugging into the function. So our function was x plus 2. So we have 1 plus 2, which is 3. So we have the ordered pair 1, 3. And now at 1, 3, do we have an open or a closed circle? Closed. And we know it's closed because of that less than or equal to. Okay, that equal to makes it a closed value. Closed dot, kind of like a bracket when we do interval notation. Okay. Our second one, 0 plus 2 is 2. So we have the ordered pair 0, 2. Now here, since it's not our starting value, we have 3 different options. It can be a closed circle, an open circle, or an arrow, meaning it's going to continue on. Okay, this is an example where you're going to have an arrow. So if we graph this, if we go to 1, 3, We have a closed circle. 0, 2, we kind of have a point. If you want to put a point there, that's fine. And then we're going to continue this line with an arrow. Okay. On your homework, you're just going to keep clicking this second dot that we did until it turns into an arrow, and then it will extend on. Okay? Yeah?
So how do we know if it's an arrow?
Arrow, because we only have one number. When you only have one number, you're going to have an arrow going whichever direction.
Okay.
Yep, good question. Yeah.
How would you know if it would be like open or closed instead of an arrow?
Hold that thought. We'll see it on the next page. All right, so number 2. Now we have f of x equals 4. If x is greater than 1. So again, we're making a table. Again, we still have to use that x value that's given. So we have to use 1. But x is greater than 1. What's another value that would hold that true? 2. Okay, if we evaluate the function for 1, do we have anything to actually plug into? No, we're going to just get what as an output? 4. And same thing for 2. So we have the ordered pair 1, 4. Is that going to have an open, closed circle?
Open.
Open. We know it's open because it's greater than. There's no equal to. Okay. And then at the ordered pair 2, 4, closed, open, or arrow? Arrow, because it's going to continue on. It doesn't matter which value of x as long as it's greater than 1. So if we plot these, we have an open circle at 1, 4, a point at 2, 4. That's going to extend to an arrow.